Motion of charged particle in electric field. For the better understanding, you must go through the previous lectures, the potential gradient and the electric field strength. I'll put the link in the description as well as on the top right corner. So, the motion of charged particle in an electric field. Here we have an electric field from positive plate to negative plate and a charged particle. It's a unit positive charge. Unit positive or test charge is always positive. We never consider a test charge as negative. So, if the test charge Q naught is free to move in an electric field, it will move from positive plate to negative plate because same charges repel and opposite charges attract. Positive, negative attract, positive, repel. So it will move from positive plate to negative plate. And as it moves, it will gain kinetic energy. If the charge is free to move, it will travel from positive plate to negative plate, gaining kinetic energy as it moves. Okay, now the second point. If we move this charge against the electric field from point A to point B, it will gain electric potential energy. So to move against the electric field, we need some external force. And this some external force and it will cover distance. Force and distance means work is done on the charge. And this work done is stored as a electric potential energy. If we move the charge by force against the electric field, it will gain electric potential energy and then released. It will move back towards the original position because it has electric potential energy. If we release it, it will move again back towards the original position. Energy of charged particle moving in an electric field. What will be its energy? As we know that work energy theorem. What is work energy theorem? I'm explaining in a simple way. Now, if I'm doing work on this duster, what is work? Work is force and displacement. Work is F dot D, force and displacement. I'm applying force and the duster covers some distance. It means work is done. Now the work is stored as a potential energy in this duster. And it has energy to damage anything that is on this position. So here the work is equal to potential energy. Now if I'm applying force and there is no change in height but it moves at the same height, same position. Now the work is converted in the kinetic energy. Here the work is equal to kinetic energy. If gesture is moving upward as well as forward, no height as well as the horizontal distance changes. Now here the work is equal to kinetic energy plus potential energy. It's a work energy theorem. Kinetic energy is measured in joule, potential energy is measured in joule, work is measured in joule. So here energy, work done per unit charge gives the potential difference between those points. If I'm doing work against the electric field, work is done on the charge Work is done on this charge if we move by applying some external force against the electric field. It applying force and it covers distance means force distance means work is done. Work is done on charge, on this charge. Gives the potential difference del V. Potential difference between these two points. Now Q will be multiplied with del V and work. Here work is as a electric potential energy. So we can put del E in the place of work. Work is then del is equal to Q del V. Q is the charge, del V is the potential difference between those points. So it's the energy of a charged particle in an electric field. What is electron volt? If instead of this positive charge, if an electron moves in an electric field of the potential difference of 1 volt, the energy gained or lost by that electron will be 1 electron volt. For example, I am putting the value of charge on electron. The charge of the electron is 1.6 multiplied 10 to the power minus 19 coulomb, and the potential difference del V is 1 volt. Then CV. CV is equal to joule because work is measured in joule, charge is measured in coulomb, potential difference is measured in volt. So joule is equal to coulomb volt. Coulomb volt is equal to joule. It's the energy. Joule is the unit of energy. It's the energy of electron when the potential difference is 1 volt. Electron volt, it is the energy of an electron moving through the potential difference of 1 volt. If the potential difference is 1 volt, so the electron moving through that potential having the energy will be 1 electron volt. Here 1.6 multiplied by 10 power minus 19, 1.6 multiplied by 19. If the unit is coulomb, it's the charge of electron. If the unit is joule, it's the energy of electron. This energy is known as 1 electron volt energy.